All right, so we're talking about sequences. One of the most famous sequences in the world is this one. 1, 1, 2, 3, 5. Do you know where I'm going next? 8. This one, it just simply is add these two together to get the next one. Add these two together to get the next one. 1 plus 2 makes 3. 2 plus 3 makes 5. 5 plus 3 makes what's the next one? 8, etc. I want you to go on until you've got 10 terms. Write these down, all the first 10. You have it up to 300?
Yeah.
What'd you do, Google it?
Yeah.
Oh, okay.
It was a long time ago and I have a picture of it.
Wild. All right. We're not going to need to go quite that far, but the first 10 will at least get you up to big enough numbers so this next little pattern is going to work. And I bet it's something that a lot of you guys know that this is found in nature. Like, for instance, I'd like to take a second after you've got it up to 10 terms and Google something. But I'll tell you what in a second here. All right, so 7th term, 8th term, 9th term, 10th term. Let's see if I can move this whole thing over a little bit so I can make that 10th term stay on the same line. There we go. Good. Okay. Did you ever know that something cool happens when you divide Fibonacci numbers? Try taking, not the smaller ones, it doesn't work because what happens is this, as you go farther and farther in Fibonacci numbers, the dividing of the two numbers will get closer and closer to this really special number. So let's start here at 21 and 13. Everybody take 21 divided by 13 with your calculator. Just simply divide the two numbers with your calculator. And take the bigger one divided by the smaller one, and it should be 1.6 something. What is it? 6.1 what? All right. Try taking 34 divided by 21. See what you get for that. 1.61 what? 9. Take 55 divided by 34. 1.617. What's the next number after the 7? Ooh, perfect. That one actually finally rounds to the right answer. As you get bigger and bigger and bigger Fibonacci numbers, when you divide them, you get 1.618. Now, 1.618 may not seem like much to you, but it was everything to the Greeks. When they built their stuff, they used this when they made their rectangles, and there was a lot of rectangles on their buildings. They always used this ratio. It's called the golden ratio. Ever heard of that before? All right. And it's not only found in Greek architecture. Have you heard of the guy who was a genius, who was a painter, painted a really famous lady? Da Vinci. Okay. You know Da Vinci, when he painted the Mona Lisa, when he did the proportions on the Mona Lisa, he used 1.618 on when he was painting that because he wanted to have the face be just perfect in his mind. Did you know that when you take the width and the height of your face and you divide them, take a wild guess what you get? 1.618. Did you know that if you took your height from the ground to the floor and your height from their belly button to the floor and you divide the bigger one divided by the smaller one, take a wild guess what you get? 1.618. Hold your arm out. From your elbow to the end of your hand and from your wrist to your elbow. When you divide those two numbers, take a wild guess what you get. 1.618. There are so many ratios on you that are 1.618. It is, or 1.618. It is scary. If you take, okay, I have this drawn on the whiteboard. It doesn't help much. I'll draw it on the smartboard here. So here's a caricature of a person, and here's their eye. And if you put a rectangle around their head from the side even, and then you draw another rectangle over that, such that this distance and this distance are my two numbers, and the whole distance, of course. When I divide the bigger divided by the smaller, and I get 1.618, guess what's right there? Your ear. There are so many places, if you actually want to Google this, you can find little charts that show where that 1.618 ratio comes up on your body in a tremendous number of places. Your hand, turn your hand sideways. Hold it out like this. Look at the width, look at the length. Take a guess what happens when you divide them. 1.618. It's almost like this signature on you that's it's over and over and over. It's like, you know, it's like that number's kind of important. Like if you were going to make something and put it on the planet Mars, and you made that thing have that ratio over and over and over again, whoever found that thing would figure out that, oh, 1.618, that's kind of important. It's like, why is that so important? I don't know. I hope to know someday. All right. So anyway, that's a cool sequence, and we're talking about sequences today, and specifically, we're going to be talking about recursively defined sequences. This is like one of these things where it's not that you need to learn how to do sequences. You've done them since you were a little kid. It's more about how to write those sequences in a really mathy, sort of a complicated way. Like for example, this, flip your notes to this one, that is a sequence that starts with 5 and then goes up 4 each time. How can I tell it starts with 5? Because u sub 1 is the first term, and it's a 5. And then it's got this thing plus 4, which means that you add 4 each time. So it would be like 5, and then plus 4 is 9, and then plus 4 is 13, and then plus 4 is 17, etc. Okay? So I'm going to take, I want you to add a blank page. Insert blank page. We're going to take one of your most common lists of numbers that you've ever seen. This one. 1, 2, 3, 4. And you can actually write that as a formula for that. Here's the formula for that. Everybody underneath this, write u sub 1 equals, can anybody remember from what I just said a second ago what it would be? U sub 1 equals 1. U sub 1 is the first term. Do you get that this is the second term, and this is the third term, and the fourth term? Okay? So these are all terms, and u sub 1 is the first term. Then, who can remember, who has a really good memory for this stuff? What do I start with for the next line of my formula? U sub n was right. Why do we say u sub n? Because this means it's like you're way out in the sequence. Like let's say I'm in the middle of a sequence and it goes like 20, 25, 30. Okay, I'm just in the middle of nowhere in my sequence. This term, what do I call it? I don't know which one it is, so I call it u sub n. I don't know which one it is, so I say n. If I knew it was like the fourth term, I'd say u sub 4. But if I don't know which one it is, I call it u sub n. Then think for a second. What's that one? U sub n minus 1. Very good. Because if this one is sub n, this would be sub n minus 1. And then, of course, this one would have to be u sub n plus 1. Do you get what I'm saying? If I pick any random term out there, it's called u sub n. And then if I go to the term in front of it, it's called u sub n minus 1. All right, so here's how you write these formulas. You need one good example for yourself, and that's where you're writing right now. U sub n is equal to u sub n minus 1. You need to copy this down, please. Stop farting around with whatever else you're doing. All right, and then what do I do each time to the term in front of it? To go from here to here, plus 1. And the last line of these formulas is called its domain, where n is greater than or equal to 2. Now that seems really weird and useless, but what it is saying that this formula works for everything except if I only let you start at 2, what number won't this formula work for? If it only works starting at the second term, where the little n thing is 2, then do you get that it won't work at 1? This formula cannot tell me the very first term in the sequence. All right, so if that went over your head, just know that this part right here, this number here is always 1 bigger than whatever that number is. So if you start at 1, then the formula starts working at 2 or bigger. On the second term, you can figure it out. All right, so one last time, if I wrote this formula, what does this start with? 50. What would the next term be? 55. All right. What wouldn't this formula work for? Where, I can't spell where apparently, n has to be greater than or equal to what? 2. So it won't work for where n, the little sub number here, is 1. It won't tell me the first term. It'll tell me the second term or the third term or the fourth term, but it won't tell me the first term. All right. Now, this is handy to use to figure out like what, oh, you can use it for lots of things. You can figure out if I put a certain amount of money in the bank, what will it be worth 20 years from now, or u sub 20, if I get a certain interest rate. There's a zillion possible uses, but all of the real world uses, you're going to need to use a calculator to do them. So I got to show you how to put this on a calculator. And first I'm going to, before we do that, that's why I had you have the calculators out. Before I do that though, I just want to make sure you're comfortable with the basics of this. So if I had this 2, 4, 6, 8, dot, 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 you get that's the even numbers, right? Write me a formula for it. Start with u sub 1. ECS. What did you get for the beginning of the formula? Okay, what did I tell you to start with? Equals what? What's the first term? Good. That's how you start. All right, I'll let you off the hook for now. Stay with me so you can ask you another question later. In the back, in the red. I don't want to say names on the recording, so. Yup. Nope. Who knows what to put after u sub n? Yes. un minus 1. What it's saying is, to get any term, I take the term in front of it. Remember how I was saying that u sub n minus 1 would be the term right in front of u sub n? All right, so to get any term, you take the term in front of it, and then what do we do to it? Yeah, you add 2 each time. Right? So, plus 2. And then does anybody have the domain on their paper or on their document? Yes? N has to be greater than or equal to 2. Always 1 bigger than that. Now, that's the basics of writing one. I can tell by how many people didn't have that I need to practice this a little bit more. I'm going to give you the formula and see if you can write the first 3 terms. U sub 1 is 12. U sub n equals u sub n minus 1 plus 4. Would you write me the first 3 terms of this? Just the first 3 terms. U sub 1 would be 12. U sub 2 is the second term, would be 16, and u sub 3 would be 20. You don't have to label them like that, but if you had 12, 16, and 20, then you got the idea. Raise your hand if you did. Okay, good. Now try it going the other way. Let's say I have 20, 17, 14 dot dot dot. Write me a formula for that. I'm going to come around and check them, so make sure that yours looks good. I'm going to pause. I'll give you a second to work. So here's what you should have said. U sub 1 equals 20. U sub n is given by U sub n minus 1. And then I have to make it go smaller each time. What's that mean? Minus 3. There's some terminology that you need to know. This is called the common difference. It's called the common difference. Get it? There's a difference between this and this, right? The difference is if you subtract them. All right, so that's called the common difference. And this part right here, where n is greater than or equal to 2, that's called the domain. That's just getting you ready for test questions, because they'll say, like, what's the domain on that problem? And you'd be like, huh? If you didn't know that this part is the domain part. All right, so let's go through some of the other slides that we have in here. You see this one? What is the common difference? 7. And it is good to put negative 7 because it is going down each time. Okay, if you were going to write a formula for that, what would you start with? Yes, 20 is the starting term, but I call it what? U1 is 20. And then it's always U sub n equals U sub n minus 1. You always have that, no matter which problem you're doing. Now it's just a matter of what do I do each time to get smaller each time? Minus 7. And then, nope, we put minus 7 because we want to go down each time. Then it says, what is the 11th term? Well, that's kind of a pain. We've already got 1, 2, 3, 4, 5. We'd have to do that 6 more times. That's where you need a calculator. Let me show you how to put this into the calculator. Yes? All right, so here's what you're asking. If I pick a random term out of here, do you get how that's just, I just picked the term? What it's saying is, if I pick a term, I look at the term in front of it, which is this one, and what do I do to the 13? I subtract 7 to get the 6. That's why I subtract 7 right there. Okay, and yes, technically this is where n is greater than or equal to 2 is the domain on that one, but I never asked for that. So what's the 11th term? I need a calculator to put this in. So would you please get your calculator, and here are the steps. First step is you go to the mode screen. You hit the mode button. It's in red on my screen right there. Find the mode button and hit it. The fourth thing down, go to the fourth thing over to the right. Do you see it says SEQ there? Fourth thing down, fourth thing over, SEQ. Get on that and hit enter. And you'll be in sequence mode. Now, this changes your calculator's y equals screen totally. Find the y equals button. It's right here. It's now red on my screen. And you see how it looks totally different now? The very first thing, yours probably doesn't have anything right here. I'll clear this out. And it probably doesn't have anything right in the next line either. But it probably does have a n min equals 1. You get that? That's what did you start with? And we're going to always start with 1 today. We'll always have our first term be called 1. Do you get how in some situations you might call your first term 0? Yeah, you can pick 0 to be your very first term. But we usually make it 1. So for right now, that's just going to be a 1. Leave it the way it is. The next line says U sub n equals. Now I know it doesn't say sub, but the calculator can't do subscripts on this screen. So it puts the little thing in parentheses. So when it says U parentheses n, that means U sub n. What you need to type in now is U sub n minus 1. So you got to find the U. It's above the 7 key. It's second 7. Brings in your U. Now you've got to do sub. Stay with me. I'm going to be checking your formula in a second. So all you have to do right now is do what I do and you'll be fine. Yes? You can't get to sequence mode? All right. I'm going to pause for a second. All right. So U sub n minus 1. I need a parentheses for sub. And then n. I know you don't see where the n is, but since we're in sequence mode, it's right here. Look what key turned red. That's where the n is. Minus 1. Then I end it with end parentheses. U sub n minus 1. The n was on the x key. It's right to the right of the green alpha key. It's the x key. But when you're in sequence mode, it uses an n there. All right? Now I got to tell it what to do. Well, for this sequence, it goes down 7 each time, so I go minus 7. Minus 7. Enter. What haven't I told the calculator yet? No, it knows the domain automatically, but you're right, that's a thing. But the calculator will do that for us. Yeah, what to start with? What was our first term in the sequence? I gotta move this over to be able to see it. It's a 20. So to tell it what to start with, that goes on the third line of this. 20. And I hit enter. Now, make sure your calculator looks exactly like mine. If it doesn't, ask a friend to help you. I'm going to pause for a second to get you in the right. Okay, now here's the cool part. To be able to use your calculator to do sequences, you can do it two ways. One is it can make a big table of all the things that go together, like U sub 1 is this, U sub 2 is that, U sub 3 is that, and that's under table. So everybody go with me, hit second, and then table is right above graph. And now there's my table. Now the very first line says error. Why is that? Because there is no U sub 0. Where's your calculator? Yes. Okay, so I'm on my table right now. And I have a choice of, yeah, my first one is 1 goes with 20, and that's what I expected. That's my first term. The next one's 13, the next one's 6, the next one's negative 1, negative 8, etc. So if I wanted to get to the, which term do I want, by the way? The 11th. I just keep hitting down arrow till I get to 11. And there it is. Okay? All right. Now, what if I wanted the 412th term? You seriously have to arrow down like 5,000 times? No. There's a really cool shortcut. Let me show you. We go to second quit to get out of that mode. And let's say I wanted to, not graph, sorry, second quit. I wanted to clear that. Let's say that I wanted to find the 20th term. Instead of going to the table, I can go U, everybody type this in, right above the 7. If you haven't already quit out of that other mode, you got to quit that mode first to get to the screen. U sub, and now, what did I say, 20th term? 20. Parentheses. U sub 20, end parentheses, and hit enter. If your calculator says negative 113, then you did it right. I'm going to come around and make sure that your calculator says what it's supposed to say. Okay, the cool part now that I know that you all have this right is go back to your y equals screen. Now do you get, what if I wanted to change this to be times by 6 each time? It's going to get 6 times bigger each time. What part do I change? The minus 7. I go down to that minus 7 and I change it to times 6. Times 6. And now, everything else, it's still starting at 20. Let's say we wanted it to start at 10. I could go change that to 10 really easy. But once you get the kind of the boilerplate for this, that's an old name for that, the kind of the stuff that needs to be there every time, then it's really easy to just change your formula and then quit out of it. Now say with my new formula, what's U sub 20? U sub 20, parentheses. Oh, I just did 7 sub 20. That's not going to work. U is above the 7. There we go. U sub 20. Enter. Did you get 6.09E15? Now, why is it such a gigantic number where I have to move the decimal 15 places to the right? Because you were timesing by 6. And you keep timesing by 6 enough times, and it gets to be really, really, really big. Okay. So, that's like our national debt kind of level. A little scary, but true. All right, so I think we have done enough that I want to actually just start your homework with you. So everybody take and find on Schoology your under assignments. It's the one assigned on 221, arithmetic sequences. It's the second one down here. Okay, and I've already got it open on mine, and it's right here. All right, do I really need a calculator for this part? No, because these first few are so easy. It starts at 20, and then you add 6, so it's 20, and then what? 26, and then 32, and then add 6 more, 38, right? That's it. Now, when we get down to like the third one down, that's going to be ugly enough that I want to put that in the calculator with you. Okay, so everybody get to the problem number 3. Slide this down a little bit. Okay, so if you're going to put that in the calculator, we just have to change our starting number from 20 or 10 or whatever we had it last to a negative 18. So I go into y equals, and my starting is not the top line, it's the third line down. That's negative 18. And what am I doing each time? I'm adding, is it adding or what is it? Subtracting? Problem 3, what does it say? Adding 4.3. Okay, so I just need to change this times 6 here to an add 4.3 plus 4.3. All right. Oh, you're right. I got 2 plus signs. Sorry, I'll fix that. Hit the delete. The calculator is going to be doing most of your work this time. Sometimes it asks you to write out your formula that you typed in. That's the way you're going to show your work on that. So if I hit enter, now I can go out of this, and I'd go to the table because they want like several terms, right? They want 1, 2, 3, and 4. I already know my first term that was given to me. It was negative 18. I go to table second, table, and I'm on my 5th term. Sometimes that happens. You got to like arrow up to where you want. Now what if your table defaults to like the 200th term? It's kind of a pain. You can go to table settings. It's right above, let me see what that button is called. It's right above the window button. Table settings, and you can change your tables to start at anything you want. I always have my table set to start at 0. So again, if I go to table, now I can see negative 18 is my first term, negative 13 is the second term, so I write them in here. Negative 13.7, negative 9.4, negative 5.1, etc. Okay? Would I really had to use the calculator on that one? No, it's pretty easy still, so you probably could have done it without the calc. But I'm telling you, we're going to get to problems where there's no way you can do it without the calculator, so you have to learn how to type these in. Now, I know some of you may be still a little foggy about that during our work time right now, which we have about 10 minutes left, 12 maybe. You are welcome to come up and ask for, no, I guess it's more like 10 minutes left, sorry. About 10 minutes left, come up and ask for help if you need help. Save.